In today's video, we begin Chapter 9, which is quadratic equations. Recall that quadratic equations is any equation that can be written in the form of ax squared plus bx plus c. Or more simply put, a quadratic equation is simply an equation that has the highest degree of the variable is the second degree. During this chapter, I want you to be looking at three essential questions. So please refer back to these questions as we learn each section in this chapter. The first one is, what kind of problems can be expressed as quadratic equations? So yes, this is a little foreshadowing that we're going to be doing some problem solving in this chapter. So think about what situations that you face in real life, what situations you face every day can be expressed in a quadratic equation. The second essential question is how do the different ways of solving quadratic equations relate to each other? Throughout this chapter, we're going to be looking at 4 different ways of solving quadratic equations. And each of these methods are there some ways they're similar and some ways they're different. So I want you to be looking at how do they relate to each other? How do you determine which method to use with which situation? And how are they different? The last essential question is, when is it best to complete the square or use the quadratic formula to solve an equation? These are the last 2 methods that we'll be learning this chapter. But I want you to be thinking about it when I introduce the quadratic, with completing the square and the quadratic formula. When should I use which method? Which situations or which type of problems work best with the completing the square method? Which situation or which type of problems is best solved using quadratic formula? I look forward to you exploring quadratic equations with you. Let's begin. Before we begin solving quadratic equations, let's review a method of solving equations we already know how to do, and that's solving linear equations. Now remember, linear equations are equations like ax plus b is equal to 0. Those equations where you have a single x raised to the first power, and there's only one solution to these problems. To review this, let's look at the example problem 2x plus 5 equals 0. Now recall, in order to solve linear equations, we had to use a process called inverse order of operations. That is, you look at the variable x and you see what operations or what's happening to the variable x, and you do the opposite operation in the inverse order of evaluating or simplifying an expression. So here, when we want to solve for x, we got to add or subtract expressions from our equation first, then multiply and divide, then we do exponents, and finally we work with the groupings. So back to our example, we look at our equation, we ask what is happening to the x? Well, we're multiplying by 2 and then we're adding 5. But according to the inverse order of operations, we need to work with this adding 5 first. And we do the opposite of adding, which is subtract 5. But remember, what you do to one side of the equation, you must do to the other side. So now we have 2x is equal to negative 5. Now we are multiplying x by 2, so the opposite of multiplying is divide. X is equal to negative 5 halves. In this chapter we'll be learning many methods of solving quadratic equations, but all of these methods require you to use inverse order of operation in order to isolate the x variable. So make sure you understand this procedure clearly. As mentioned in the introduction, a quadratic equation can be written in the form of ax squared plus bx plus c equal to 0, where a is not equal to 0. Now the difference between a quadratic equation and a linear equation is this time we can have 2, 1, or 0 real solutions to the problem. Our first method of solving quadratic equations is called the x squared equals k method. Now use this when you only have an x squared term, so only one term with the variable in it. And it's done very similar to the example problem we just did, in which your goal is to get the variable by itself using inverse order of operations. Start by asking yourself what is happening to the x. So I'm multiplying x squared by 2 and adding 1. So let's get the x squared by itself. So I need to do, I'm dealing with the addition first by subtracting 1 from each side of the equation. And now I'm multiplying x squared by 2, so that means I need to divide each side by 2. And now I need to worry about the exponent. Well, the opposite of squaring something is taking the square root. Forget the plus or minus sign because negative square root of 7 squared and positive the square root of 7 squared both equals 7. To solve example 2, we look at what's happening to the x squared. Well, I am multiplying negative 3 and adding 2, so I need to deal with the addition of 2 first. And the opposite of adding 2 is subtracting 2. So what do I do to one side? I have to do the other side. Now I look, x squared is being multiplied by negative 3, so that means I need to divide each side by negative 3. Then I take the square root of each side. But I notice a problem here. Anytime I take any number and I square it, there's no way I can get a negative. Any number squared is positive by definition. So therefore, this is an example where we have no real solution to the problem. Example 3 will really require you to know your inverse order of operations in order to solve it. So here, in order to get the x by itself, I notice I am raising it to a power, and then I have grouping in parentheses. So I got to do the exponent first. So I have to take the square root of each side before I can worry about adding or subtracting the 2. Now that I take the square root of 25 and got plus or minus 5, I look at what's happening to the x. Well, I'm subtracting 2, so opposite of subtracting 2 is adding 2 to each side. And notice that these are two solutions. I have x is equal to 2 plus 5, and 2 plus 5 gives us 7. And I have x is equal to 2 minus 5, which is negative 3. So our two solutions to this problem is x equals 7 or x is equal to negative 3. Example 4 is solved very similarly. So let's start by taking the square root of each side. So that would leave me what's inside the parentheses, x plus 1, equal to plus or minus the square root of 7. Now I'm adding 1 to each side, so the inverse of adding 1 is subtracting 1 from each side of the problem. So that gives me the answer of x is equal to negative 1 plus the square root of 7 and x is equal to negative 1 minus the square root of 7. You have successfully learned how to solve our first method of solving quadratic equations. That's equations in the form of x squared equals k. Remember, the key to this method is to isolate the variable by using inverse order of operations.